Okay. Alright, so we're live. Let's check the mic. Mic is working good. Okay, so welcome back, guys. Welcome to this OpenFOAM video. Again, we're going to pick up where we left off the last time. Yeah, so first thing first, I would like to just ignore, I'm just changing some settings because there was a problem with the last Spotted Omerous simulation. Okay, but I'll get to that shortly. Maybe in a few videos coming down. But before I continue, talking about the Spotted Omerous case, because actually there were some problems with it, and I have to make changes to GitHub, at least some of the input files, in later videos. But that's one of the things that I want to discuss maybe later on. But in the last video, we also discussed, how easy it was for the K-omega SST RANS model to be swapped into a K-omega SST IDDES model. And we could do the same for the Spotted Omerous model as well. It was easy to change the syntax because most of the variables we solved for were the same. Okay, and that's kind of the gist of changing turbulence models, the syntax of it anyhow. So so I want to go, before I go into this discussion on the Spotted Omerous case and talk about some of the issues that came up, we'll quickly go into looking into other LES models. One of them is called the Smagorinsky model. Okay, the Smagorinsky model is actually the most basic of all large eddy simulation models. It's one of the first actually. So if you come into turbulence modeling, so the first model they'll tell you about is the K-epsilon model for Reynolds average Navier-Stokes. And likewise for LES, when you come into that, they will introduce you the simple models first. And the most simple model here is the Smagorinsky model. So the Smagorinsky model is kind of the starting point of all large eddy simulations models. They'll introduce that to you. So going into Spotted Omerous and K-omega SST IDDES for the first thing for LES model was kind of complicated. You normally start, theoretically speaking, with Smagorinsky. But I did the Spotted Omerous and K-omega SST IDDES models first because actually swapping over the models from, at least syntax wise, swapping over from K-omega SST to K-omega SST IDDES, and likewise similar for Spotted Omerous, was actually relatively simple. Alright, so I would like to let's get the OpenFOAM template over. Let's do a Smagorinsky. Okay, LES Smagorinsky. Okay, Smagorinsky. So some background. Smagorinsky model is actually the first, one of the first LES models developed back in the 1960s-ish period, 1960s-ish, and it was actually developed for atmospheric turbulence. All right, atmospheric turbulence. If you want to know more, do go check out the turbulence modeling video series I have. But it's kind of a starting point for people. So before I do it, let me do the auto patch mesh gen first. Okay, now let it run. So let's start editing the model. Okay, let's start editing what we need, what we know. We go to constant and we go and edit the turbulence properties. Okay, simulation type is large eddy simulation. As you can see on the left, the auto patch is running, so good, we're making the mesh generate. So LES model, we want it to be Smagorinsky. Alright, and let's see, what else should we put? Well, let's check first whether I spelled it right. Okay, list turbulence models. Okay, Smagorinsky has to be spelled with a capital S. Sure, let's put a capital S in there. Okay, so everything else I don't change first. Let's see what errors we run into as we go. Then we'll start from there. So I'm just gonna be just running PimpoFoam first. You'll probably run into an error, and wow, it looks okay. Yeah, looks like this syntax actually works. It is that simple to set. Okay. Of course, I have a different kind of a delta here. Because delta actually is it's a way to determine the turbulence length scale. Smagorinsky may not use this IDDES delta, so to speak. Okay, it may not use this IDDES delta, so it may use something else. But let's take a look at foam tutorials and see whether there's any model using Smagorinsky. Okay, and what you will see is that there's this one in the PimpoFoam ISO decay ISO turbulence. Okay, so let's go there and we'll see turbulence properties here, and wow, it's great. They use a C++ code here. Then include / turbulence models. That means most of the stuff you'll see is in some other files. Okay, it looks like this particular model used here is a K equation, so it's not exactly Smagorinsky. Okay, so let's go into the include, and you can take a look at turbulence models here. Okay. So you'll see input files for several equations. So depending on okay, let's take a look. This is a rather interesting file structure. Okay, depending on the way this case is structured. Okay, let me try and explain it for you. So this is C++ code, right? This is C++ code. Turbulence properties, yeah. Alright, this C++ code, simulation type is LES. They have this include here because they are using this line to say, hey, I'm trying to reference a new file, and this file is inside this folder called include and turbulence models. I mean, relative to where this input file is, the turbulence models here is, or turbulence properties here is. So the simulation type is LES. Okay, simulation type is LES, and the turbulence is on, print coefficients is on, so it's nothing too new there. And what they selected an LES model here, which is a K equation. So once the K equation is put here, what OpenFOAM will do is to read this next line, and then it will be reading this. It says please look for the turbulence model. So if you put K equation here, OpenFOAM will actually read this as like a $K, the K equation, so to speak. So the rough gist of what it does is it will go into the include file, you go into the turbulence models here, it will look for an entry called the K equation model. So K equation is over here, and it will say, okay, over here I have a delta which is a cube root volume and the K equation coefficients as such. So depending on the model you use, it can be a whale model, can be a K equation model, can be dynamic K equation model, or it can be Smagorinsky model. So depending on the model, it will look for these entries over here, and it will change it accordingly. Now, of course, you don't have to use the delta that they prescribe here. Like you see here, the delta I use is the IDDES delta, which is not actually meant for Smagorinsky model, but syntax-wise, the equation solves anyhow. So you don't actually need to worry too much. Okay, in terms of the syntax, so to speak. Okay, so can go to turbulence properties, and let's copy everything we see here, and I'm going to paste it. Okay, let's let's delete all of this, and okay, I'll give it this one. Okay, the delta is the cube root volume, and you have this Smagorinsky coefficients as such. Alright, let's go to OpenFOAM website. I'll show you some, yeah, I'll show you some other entries you can put, I guess. Yeah, so here are some of the pure, you see the pure large eddy simulation models. So this is a Smagorinsky one, and you can have these coefficients. All right, so there's nothing really much to do except, you know, maybe change the delta. So where you will see this delta found is in this cube root volume. Okay, cube root volume is one of these entries here, which you can specify. Delta being the cube root volume. All right, or you can have the Driest model given by this equation. Driest is actually, you know, one of the ways they try and the taper off, or at least reduce the turbulence viscosity artificially close to the wall. So that's what the Driest model does. It's like a wall function for turbulence viscosity. All right. I hope you know what I'm talking about. If you are kind of new to all of this, please do again watch my turbulence modeling series. But anyway, yes, I think I said that a little too many times, but yes, I will just assume you know it. It's a prerequisite if you want to understand all of these. But these are the syntax you will probably use. The one we use here is cube root volume, and this Driest is a different syntax. So depending on what sort of delta you want, you will just change the values accordingly. You can actually just copy all of these entries and, you know, just paste them here and edit it as you like. So that's basically how you edit your Smagorinsky model. Okay, so let's try again. We can do pimple foam. Okay, and it runs nicely. Okay, so I'm gonna stop. I'm not gonna do a full calculation. All right. I also want to, you know, kind of repeat this thing for the dynamic K equation and whale accordingly. All right. So at least to show you what writing the syntax is like, I'm not gonna run the full case. At least give you somewhere to start. Okay, pimple foam LES K equation. Let's make one. Oopsie. Smagorinsky. Let's do the Smagorinsky one. Okay, pimple foam LES K equation. Alright, so let's do one for the K equation, and we'll do one for the whale. And okay, before I do anything of that, I got to change some boundary conditions. Alright, actually inside the 0 original file, epsilon, k, and omega, they will all be calculated. The type of boundary condition for them, it's all calculated, because you will not have anything in there. Okay, all of this will be so-called calculated. You can actually just remove them. All right, so you can go to epsilon, and I'm just gonna copy and paste. This is what you need to do. Okay, and I'll just delete all of this. Okay, because Smagorinsky is not, the model actually uses a different way of calculation. It will operate on new t directly. All right, so all of this I can just delete, and I'll just put calculated over here. Okay, so vi omega is calculated, vi k is calculated, epsilon is calculated, and nu tilde should be calculated as well. Alright, so that's calculated, and we can, yeah, this is roughly how you should set up your case. Alright, let's do an auto patch again to see whether it runs. Alright, let me open another terminal window. Then yeah, let's cd to here, and while it's running that, I want to remove the k equation first. So k equation, you sort of have it slightly different. The way you write these boundary conditions will be different. Okay, so okay, look at the left hand side, auto patch is running and PimpleFoam starts to run. Okay, and it's solving nicely. Okay, so I'm going to stop. At least the syntax is right. I'm going to do an all clean. Actually, no, I'm not going to do all clean. I'm going to copy over before I do the all clean so that I don't have to run this auto patch stuff again. So let me go and copy it. Okay, never mind. I'll just copy directly from LES Smagorinsky, and I'll change it to LES k equation. Alright, PimpleFoam LES k equation. So I will just quickly change the entries in there without changing the boundary conditions, just to test if you know the thing works. Okay, so I'm not going to use Smagorinsky anymore. This time I'm going to use k equation, and I'm going to use this delta. Okay, so it's very simple to switch around between LES models, at least in the sense of just changing the turbulence modeling part. The rest of it should run pretty well. Okay, I'll leave the alpha k entry there so you know that we can actually just edit as and when we please. So this is the cube root volume. Okay, k equation is this one. Control Shift, yeah, C and V. Okay, I think I forgot one line. Okay, there you go. Okay, let's save and quit. Try running this. Clear. PimpleFoam. Okay. Yes. It will give you some error because I didn't set my k equation boundary conditions right. So I need to go to 0 original and start looking for the k. The k should not be calculated here because you're not calculating. Alright, hold on. Yes, I think I forgot one more thing. Let me deal with the Smagorinsky part first. I just realized I forgot to edit the Smagorinsky bit. CD0 VI new T. Yes. None of this should be calculated. You should have hold on, yeah. Yes, anyway, you should not have this as a calculated here. You should have it proper fixed value and everything. So where do I put this? Now we can go to new tilde. Alright, never mind. I'll go to the Spalot Almaraz type because we already calculated our new tilde there. Okay, I want my my new T to look exactly like this in terms of boundary conditions, except for the wall. So I'm going to copy all of this. Okay, time is up. I should not take too long, but let me finish this up first. Yeah, behind new T for Smagorinsky, or rather let me put it in a 0 original so that we can, you know what, okay, never mind, I'll just stop here and I'll continue in the next video so I don't take too long. Okay, see you.